Hello and welcome to another one of D's ADD videos. Today we're going to be discussing second order differential equations. We're going to look at an example, a homogeneous example. Again, this is the general form, and f of t equals 0 whenever it's homogeneous. Real quick, we're going to set up a characteristic equation in which the power represents the power of the derivative. It's going to give you the exponent of your characteristic variable r. Then you solve the equation. There's three basic solutions. Today we're going to look at the two real distinct solutions right there. Okay. So here's our example. First step, if you remember, is to set up the characteristic equation. So let's do that. So it's going to be r squared minus 3r minus 18 equals 0. Next step is to solve this. I'm going to factor this by grouping, just in case you forgot how to factor. Most of you can do this one pretty easily and see it's going to be r minus 6, r plus 3. But just in case I give you one that's a little more difficult to factor, I'll refresh your memory on factoring by grouping. Negative 6 and 3 multiply up to negative 18, yet when you add them, they give you a negative 3. So you break this middle term up into those two terms. Doesn't matter the order. Factor out what's common in the first two. This is factoring by grouping, so you group the first two together. Do had over factor to figure out what's left. It's just basic algebra. If you need to go back and review it, go back. I'd hate for you to miss your differential equations question because you don't know how to factor, but I see it all the time. Or you don't know how to integrate or derive, whatever the case may be. So you see how the r minus 6 is common to both of those. Pull it out in front. You'll be left with these coefficients in front. So r plus 3. Yes, most of you could have done this in a lot quicker fashion just by guessing, but guessing doesn't always work. So just in case, I wanted to show you, refresh your memory. If you need to go back to the algebra site and look at the different ways to factor, please do so. Being humble enough to refresh your memory will take you far in life. So there are my two distinct real roots. So I go to the general equation for that. If you remember, it's c1 e to the r1t plus c2 e to the r2t. Okay, so if I write that down, then you can plug in your R1 and R2. So here we're going to have C1 e to the 6t. Doesn't matter which one is which. Okay? So you could be given some initial conditions, something like, y of 0 equals 1, and then you'd be given y prime information as well, because you'll have two unknowns here. So if I were to plug that in, I'd have 1 equals c1 e to the 0 plus c2 e to the 0, which is 1 equals c1 plus c2. I can't solve that. I have two equations or two unknowns in one equation, which anytime your variables exceed the number of equations, you cannot solve it. So you need another equation, and that comes from a second set of initial conditions. So if you were to take the derivative of this, for instance, we need the 6, right? Derivative of e box is derivative of that box times what you had originally. So it'd be 6 c1 e to the 6t plus, well, actually it'd be minus negative 3 c2 e to the negative 3t. Using the same conditions there, we would get 1 equals 6 6c1, e to the 0 then becomes 1, plus, or actually minus 3t. Sorry, not 3t. Early in the morning, brain needs to wake up. So it'd be c2 there, e to the 0t. And then you can solve the system of equations, either, solve for c1 right there, or c2. So c1, for instance, would be 1 minus c2. Plug that into here. Sorry about that. So 1 minus, oops. Let's make that a c2 right there. Let's c1. It's a lot easier than erasing all the rest of that. So 1 minus c1 there. It doesn't matter which one you solve for first, as long as you solve for 1. So 6c1 minus 3 plus 3c1. So once you get c1, you can solve for c2. And then you would need to add this 3 over both sides. So c1 equals 9/5. Then you plug into there. And you'd get c2 is equal to negative 4/5. And then you can plug in to your general solution what c1 and c2 are to get your particular solution. And this is, oh yeah, that was the derivative, sorry. So this was your general solution. So if we go here and we plug in the c1 of negative 4/5 plus c2, which was 9/5. I have those backwards? Yes, I do. Actually, yeah, it does matter, because your c1 is associated with 6t exponent, so it would be 9/5 here, minus 4/5 there. Okay, so this would be your particular solution. It's early in the morning. Let me double check, make sure I didn't make the same mistake twice. C2 is negative 4/5, negative 4/5. All right, good. So that would be your particular solution there. That would be your general solution. All right. So recap real quick. Find your general, your characteristic equation, solve it, factor. It's 2 distinct real roots. This is the general solution for 2 distinct real roots. Plug in, that's your general solution. You might be given initial conditions. If so, solve. You're going to have to take the derivative, plug in, get the system of equations, and solve them. Okay? So I hope I've eliminated some doubts. You've seen the basics now. So practice, practice, practice. That's the most important part. And check out the other 2 example videos. There's one for repeated roots and one for 2 distinct real roots. Thank you and have a nice day.